Hello everyone. In this lesson, we will continue from the previous one and learn how to use vision system to guide Fanaker robot to complete PLC programming and robot programming of the motor assembling task. Next, let's learn PLC programming of vision-guided motor assembling tasks. First, let's take a look at the data transmission between robot, PLC, and camera. The process of the industrial robot controlling the camera to take pictures and receiving camera data is: the industrial robot sends the camera shooting instruction to the PLC, and the PLC controls the camera to take pictures. After the camera takes pictures to identify the shape of the workpiece, the camera feedback data is sent to the PLC, and the PLC then sends the data to the industrial robot. To realize the above process, we must first write the communication program between PLC and the industrial robot. To realize the data interaction between PLC and the industrial robot, and then write the communication program between PLC and the camera. To realize that the PLC to control the camera to take pictures and receive data feedback by the camera. Next, we need to create a variable table on the PLC side to receive the data sent by the camera, as shown in the figure. The PLC needs to receive X, Y coordinates, deflection angle, color, workpiece type, data of the workpiece. Then, let's take a look at how Fanaker industrial robots control industrial cameras to take pictures through PLC. Q 4.0 at note number 1 means that the industrial camera is in a ready state, and note number 2 means that if the data sent from the corresponding data interface of Fanaker industrial robot is 1, the contact is turned on, and Q 4.1 at note number 3 triggers the industrial camera to take pictures. Next, please answer this question. A. CMD ENBL B SOS RDY. C. Q 4.1 D R1. I will give you 5 seconds to think, and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's keep going. So, how to send the X and Y coordinate values of the flange to the industrial robot? The workpiece position data sent by the industrial camera to the PLC is a real number. When the PLC communicates with the Fanaker robot, the data type is an integer, so the PLC needs to convert the workpiece position data into an integer before sending it to the industrial robot. When necessary, for preventing the loss of position data and causing the industrial robot to grasp the position inaccurately, the PLC side also needs to enlarge the workpiece position data sent by the industrial camera 100 times before sending it to the industrial robot. Next, please answer this question. In vision-guided motor assembling tasks, how to prevent the loss of position data and ensure the accurate grasping position of industrial robots. A. Increase the resolution of industrial camera. B. Improve the operation speed of PLC. C. Enlarge the workpiece position data 100 times before sending it to the industrial robot. D. Using higher precision robotics sensors. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's keep going. Continue to send the angle value of the flange and the flange identification result to the industrial robot. In the figure below, at node number 1, you can see that for preventing the loss of angle data, the angle value sent by the industrial camera to the PLC is multiplied by 100 and then converted into an integer and sent to the industrial robot. Number 2 indicates that if the workpiece identified by the industrial camera is a flange, the PLC will send 1 to the industrial robot. Continue to send the color identification result to industrial robot. Judge the color of the workpiece. When the workpiece color recognized by the industrial camera is red, the PLC sends 1 to the industrial robot. When the workpiece color recognized by the industrial camera is yellow, the PLC sends 2 to the industrial robot. When the workpiece color recognized by the industrial camera is blue, the PLC sends 3 to the industrial robot. Next, let's learn robot-side programming of vision-guided motor assembling tasks. First of all, we need to know which registers are used by the PLC side and the industrial robot side to send and receive. As shown in the table, is a display of the correspondence relationship of the data sending and receiving registers. Let's continue and look at the teaching program on the robot side. The general idea is to establish a subroutine 法兰判 XY 角度 to obtain the XY coordinates and angle values of the workpiece sent by the PLC side. The subroutine will assign the calculated compensation values to the compensation value corresponding to the y direction of PR. Turn 1. The compensation value corresponding to the x direction of PR. Turn 2. And the angle compensation value corresponding to the workpiece corresponding to PR. Turn 6. Respectively. The whole subroutine is as follows. Next, please answer this question. What are the main functions of the robot side subroutine 法兰判 XY 角度 A. Control the camera to take pictures. B. Receive and process position and angle data of workpieces. C. Perform the actual assembling action of the motor. D. Monitor the productivity of the assembling process. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Okay, let's keep going. Next, let's look at the 法兰盘装配 flange assembling main program. The general idea of this program is to first control the camera to take pictures, and then call the subroutine 法兰盘 XY 角度 to obtain the XY coordinates and angle compensation values of the workpiece, and then use the offset instruction on key grasping points to add these composition values. Finally, realize the correct flange assembly. Everyone, in this lesson, we learned about the programming of the PLC side and the robot side for the version-guided motor assembling task. The key points are the data transmission process and the programming mindset. I hope you can master these basic ideas first and then optimize them. Everyone, that's all for this lesson. See you next time.